Good day everyone, especially to you Mr. Johnny Pagtayo, and I am Dr. Lumanan from BS Agriculture on Track. This video presentation is all about the reverse mutation. Reverse mutation. When a mutation changes the wild-type normal genotype to a mutant type, as is more often the case, the event is called forward mutation. This is in contrast to reverse mutation, in which the mutant genotype changes to the original wild type. In microorganisms, autotrophs reverting to prototrophs are easily detected by fleeting cells of the original autotrophic strain on minimal medium. In bacteriophages T4, the RL mutant strain which cause rapid lysis of host cells frequently refer to the wild-type RL plus strain. In Drosophila, a number of recessive mutant genes are known to refer to the wild-type though with a lesser frequency than the forward mutation. The ability of mutant gene to revert suggests the mutant, at least in some cases, is not a permanent, irreversible process. Reverse mutation could occur in different ways. In a true reverse mutation, the original base pair sequence of the wild type may be restored. Thus, if a GC pair of the wild type sequence is replaced by an ET revert or pair to produce a forward mutation, a true reverse mutation could again substitute a GC by pair in that position. Sometimes, an apparently reverse mutation is due to a second supersome or supersome mutation, which suppresses the effect of the primary mutation so that the phenotype appears like the wild type. There may be intragenic suppression when the second mutation occurs within the gene carrying the first mutation but in a different site. Or suppression may be intergenic or intragenic when the second mutation lies in a different gene. In both types of suppression, the second suppression mutant produces functional products of the gene which carries the first or primary mutation. For example, suppose a gene A is not able to produce IE protein due to a mutation, but a suppressor of mutation in the same or in a different gene could result in the production of a protein, thereby reversing the mutation at GA. In the case of intergenic suppression, in terms suppressor gene denotes the gene which has a second mutation suppressing the primary mutation in another gene. The products of suppressor gene are usually components of the translation system. The suppressor molecules are frequently the tRNA molecules. In intragenic suppression, reversion to the normal phenotype might be caused by deletion and insertion of a single nucleotide in the same gene. Thus, if the reading frame of triplets is shifted due to a single deletion causing primary mutation, the frame will be restored if a single insertion occurs at the site of the second mutation. Normally, amber, ochre, and opal are nonsense mutations located at sites within amino and the result of fragments of polypeptide gene. The suppressor of gene for its nonsense mutation allows insertion of amino acid at the site of the nonsense codon and the gene is not terminated. The suppression of a gene terminating mutants is brought about reading of the nonsense codon as if were a sense codon. For example, one kind of amber suppressor insert amino acid tyrosine against the nonsense of codon UAZ. The suppressor genes produce a mutant tyrosine specific tRNA. The normal tyrosine tRNA has the anticodon GUA and recognizes the terms USA and UAU in mRNA. The anticodon in the mutant's tRNA is changed to CUA, which pairs with UAG and tyrosine is inserted instead of the genes terminating precociously. Only the triplets between the deletion and insertion would add incorrect amino acid. The rest of the genes that will be normal if the site of the second deletion is close to the first, the number of wrong amino acid would be small and a full lean functional protein would be produced. Another example illustrates enterogenic suppression in E. coli. A primary amber mutation in E. coli had genes updates triplets into a nonsense codon of UAG. Some other cells of E. coli carrying the same mutation had an enterogenic amber suppression mutation in a gene coding for serine tRNA. The suppressor gene produces mutant tRNA molecules with an altered anticodon that called recognized EUG. Thus, the suppressor gene called insert serine at the site of the nonsense triplets EUG and volved polypeptide genes called reform. Both UAG and UGA suppression act by changing the anticodon in a specific tRNA and producing mutant suppressor tRNA is the mechanism of UAA suppression is not fully known. The amber suppressor genes also extend the occurrence of conditional mutation or mutants in T4 bacteriophage. The amber mutants of T4 were found to grow on the strength of E. coli called permissive host, but not in another strain called restricted host. This was because the permissive strain of E. coli carried the amber suppression gene, which refers to the effect of the amber mutation. Cells of E. coli which do not have the amber mutation gene also show the amber mutation.